We'll start sort of with from the younger children and then move up through the years. So we're just going to have a look at some digits on the paper, and we'll just swap across to there. Now, last week there was a question how we did this. There's someone else in the room doing that for me. So we're just going to swap over and have a bit of a look at these digits that are on our bit of paper here, and you can have a look. Now, you probably notice here, there's our standard set of digits from 0 to 9. And with that set of 10 digits, we can create any number. Now, essentially, until you get past 9, there is no need for place value. But as soon as we get past 9, we recycle the digits a little bit. So, for example, we get to a number like 10 by just using those 2 digits. Or we might get to a number like 13, the dreaded teen numbers, sitting there by using those digits. But of course, we can make much larger numbers. So I could make 6,547 just by combining those digits. So a very simple explanation of what place value is, and I got this from a year 4 child, was where the digit sits makes a difference. So you can see here, this digit 6 is sitting in the thousands place. This digit 5 is in the hundreds place, and we'll talk about variations of that as we go. But I thought we'd start fairly simply to begin with, and lots of children will struggle with things like the teen numbers, and it's typically an issue for us in English-speaking countries because in this case here, we say 13, but you hear the 3 first. And so it's quite common that children reverse the digits because they're hearing the 3 first. So a couple of things that I would suggest that we might do. One is, now you could either use pop sticks, you see some pop sticks there, or you could use matchsticks to do the same thing, but essentially we'd be bundling sticks. Now, used to call these things trading games. In other words, that you would bundle 10 ones, and once you get 10 ones, and you notice they've got 10 sticks here, you would trade those 10 ones in for, and I've just already pre-bundled these sticks into one bundle of 10. And so you start to see the notion, sometimes they call it trading games or things of that nature. And what I really like is, if I was playing with children, I like someone to be the banker. So in other words, you hand over this bundle of 10 for your one lot of 10s, and they get to see that 10 ones is the same as 1 10. Eventually, of course, you'll bundle those. When you get 10 10s, you'll get 100. And so that's just the notion of the trading or that sort of idea. And we can play little games like race to 90 or race to 99. And in that one there, what I tend to use is a place value mat. So I'll show you what I mean by a place value mat, and we'll just look at the same idea. I'll just pull those digits off here, and I'll just put on a place value mat. You can see it on the screen. And essentially what we've done is divide it up into 1s, 10s, and 100s. And what we're doing here is, there's a pretty simple rule. Temporarily, you can have a number of sticks that sit here, but when we finish doing all our trading, you can only have 9 sticks here. If you have 10 sticks, then you have to trade them for 1 10. And so if we were playing a trading game, we would use dice. Now we can either use, I quite like to use 10-sided dice. You'll see them there. They have the numbers and the digits 0 to 9 on them. But if you don't have those, you can use 6-sided dice. They would work equally as well. And all you do is you roll the dice. And in this case here, I've got 9. Let's say I got 5. Then I'd put 5 sticks into this spot here. If I then rolled again and I got 8, I would put 8 sticks here, which would mean I'd have 13 altogether. But 13 things can only live there temporarily. I swap 10 of those things for one lot of 10, and then there'd be 3 sticks left over. And so we start to get the idea of this place value, things being in a place that sits there. So let's just talk about a couple of other things to do with place value. So essentially what we're doing is just building the numbers, getting them larger and larger and larger. So obviously our first attempt is single digit numbers, then go to 2-digit numbers. We've talked about the issue with teen numbers and how, particularly in English-speaking countries, you hear that like the 3 first, whereas in other countries or other languages, you often hear about the 10s first. And then we've got the 2-digit numbers and so forth. Now, just to help you a little bit with that, we've put a few games up on the web, which you're welcome to download at your leisure. but I'll just get this out of the way and I'll show you an example. So this one here, you can just download that game just off the web, and it's just called Teens Place Value. Now, last week, you might remember, maybe you're new this week, I showed you how to use a pen, paper clip, and you make a spinner, or we're just going to use a plastic overlay spinner in this case here. Now, the way this game is played is fairly simple. You spin up a number, in this case it might be 18, and I'm looking for a representation of 18 to put my counter on. So for example, a representation of 18, you might spot it here, and I'll just point it out to you. 10 and 8 would be an example of 18, and I could put my counter on that one. However, there's another representation of 18, and there it is there. And there's another one here, 1, 10 and 8 ones. In fact, there'll be about 4 representations of 18, and I could have put my counter on any one of those. Now, the aim of the game, essentially the second player has a spin, and in this case here, they've got, say, 14, so they could put it literally on 14, or 1, 10 and 4 ones. And the aim of the game is to get, like a bingo game, to get 3 of your counters in a row, column or diagonal. So that's a teens version of that game. Now, once you've played that game, you really do understand how to play the others. So I'm not going to go in any great detail here, but an example would be this one here. They're 2-digit numbers that would sit there. And then we've got another version, which is the idea that we've got, in this case here, different representations, and you'll start to see the 10s and 1 idea. You might just spot it up here. You play exactly the same way as the other games. So just let me reiterate there, and I'll take you back to this sort of idea. Essentially, we just looked at 3 basic game ideas. You could use anything to cover the cells. I just use counters, but if you've got buttons or something similar, you're welcome to download them. They'll just sit in a little section called A4 Games that you can download from our website. Feel free to do that. And essentially, you can either use your paperclip spinner and play that sort of game. Be careful to talk about the language. So we've got 10s and we've got 1s. There's different ways to represent those numbers. We just want to emphasize that with the children. So that's one idea to build that sort of thing. Now, what happens is that place value just builds to 3-digit numbers, 4-digit numbers, 5-digit, and just gets bigger. And of course, then we get to a thing called place value. Now, you're probably familiar with not just bundling sticks, but you might be familiar with MAB, that's multi-base arithmetic blocks, sometimes called base 10 blocks, Dean's blocks. They go by different names, but essentially they look a bit like this. Unfortunately, I didn't have any in my house, but I'll just show you what they look like. I've got a picture there. You might be able to spot it. Let's show you there. You'll see we've got them there. I'll just turn this around so you can see it a bit better. So you might be familiar with the large cube and the flat and the long and the small cubes there. So essentially, 10 of those will make one of those, 10 of those will make one of those, 10 of those will make one of those. And that helps us get this idea that every time you move one place to the left, essentially what you're doing is multiplying by 10. So let's have a look at another idea just to build this sort of thinking a bit. So essentially we have what's called, the fancy name is a multiplicative place value system. So I'll explain what I mean. And this time I'm going to make use, look, a calculator will do, but you may not even have a calculator at home. So essentially your mobile phone will have a calculator app in it, or your tablet, the same sort of thing. So what I'm about to show you could work on anything. We're not going to do this to do a calculation. What I'm going to show you is a couple of ideas so you can see how things change in terms of place value. So I'm going to start with the calculator, and I'll start very simply for young children, and then we'll just build up as we go. Okay, so this activity I'm going to call start and step. So very young children need to be able to count, and you may be able to see that the calculator is set on 0, and I'm just going to press +1, and if I keep pressing equals, you will notice that the calculator starts to count for me. So if I'm very, very little, I just need to learn how to count, essentially. As I get a bit older, I should be able to know what's going to happen next. So you notice that we're on 7 currently at this one here. Now, I would then say to the children, can you close your eyes and hover your finger above the equal sign and press until you think the display shows 12. So now with your eyes closed, I've got to go 8, 9, 10, 11, 12. And yes, I've got there. So I did a counting on sort of idea. Now we're into things called teen numbers at this point here. So we're starting to build that idea and build that idea and build that idea. Now, if you wanted to raise that idea a little bit further, watch how I'm going to take you into a slightly different place here. So essentially, we've got the calculator. We have a starting number, which is 0. The step happens to be 1. Now, if I was doing something, for example, on tables today, we could be starting number of 0 and keep stepping in 5s, and that'd be your 5 times table. Or we could start at 0 and step in 7s, and that would be your 7 times table. But maybe that's the topic for another webinar a little bit later. So let's go back to the calculator. And now I'm going to show you a couple of other things that you might like to do. I'll clear the display. Still showing 0. So our start number is 0. We're going to add 1. So we're going to count in 1s. But this week, James Bond has been on our TVs every night. And there's a very famous James Bond movie called Goldfinger. So I like to play Goldfinger with the children. And essentially Goldfinger is you give them 15 seconds to tap that equal sign as quick as they can. And then imagine I had that sort of time there. And then I get them to work out what's the largest number they make. Now, that's a pretty simple idea, but imagine that we were counting in 10s or counting in hundreds or counting by 0.01, for example. So let me give you an example of that. So I'm going to clear my display. And this time, we're not going to start at 0. I'm going to start at 1/100th, which to enter in the calculator is 0.01. So that's 1/100th in terms of that. Now, if we keep adding in hundredths, you'll see that we're now 0.02 or 2/100ths, 3/100ths, 4/100ths. And so now we've raised right to about at least year 4, 5 in the school. So you start to see how we can take the same idea and it develops a lot further. So that's just a couple of things to do with the calculator. Just to show you one more because you'll have access to that sort of idea and we'll play with that sort of in a minute. So what we've just done is start with a number and we can step. By the way, we were stepping forward. We could also be stepping backwards by subtracting. We're not going to do that today. But it's the notion of we can be working at whatever you like. So that last time was 2 decimal places. We were in the hundredths place. Now, some children don't hear the th, so you need to sort of explain, not hundreds place, but the hundredths place. And I should probably make one little comment here. I do get a lot of children ask me why there's no once place. So I just need to explain that before we do the next little exercise. I'll explain what I mean here. So I'll just write on here. So I'll just show you what I'm doing. And look, I've got to do a little plug here because last week the people at East Point saw this webinar and they said, thanks for showing off their Show Me pen. So, and they're made in the UK. So they get made all the way to Australia. But sitting here, let's take a number, for example. And I'm going to put this one here. Now, lots of children think that this is in a place called the once place, because what they're trying to do is put a symmetry about the decimal point. There is no symmetry about that. It's all about the ones place. And so if you look at the ones place, we've got tens here, but we've got tenths there. And so sometimes some children have a bit of a misconception about that. So just bear that in mind. The other issue, of course, is how you read these numbers. In order to really read this, we've got to go to the last place here, and that's the hundredths place. And so there's a lot of language associated with the use of with place values. So it gets a bit tricky when we start developing that language, but don't get too worried. But I just wanted to explain why some children think there's a once place. It's sort of a fairly natural thing that they might expect. So now let's just play with a couple of other ideas just to build that sort of thinking. Now, I will use the calculator another time just to show you a pretty simple game. But as I play this game, listen to the language that I use because that will make a difference to children's understanding when they play. So I'll just give you the rules before we start. The game's called Wipeout. And essentially what happens in Wipeout is you would choose whatever size number you like. I'm going to use a 4-digit number. For younger children, it could be a 3-digit number. For older children, a 5-digit number. bit older, we could go to 2 decimal places. It doesn't really matter. But it basically works the same way. I'm going to put some digits into the calculator. They'll be different. So when you play this game, the digits will all be different. And then I'm going to get you to subtract to wipe out a digit. So I'll show you what I mean. So I'm going to put the calculator down, and the number that I'm going to put into the calculator, let's go for 2,564. So all the digits are different. So I've got 2,564. Now, you're only allowed to subtract. So I would say, oh, I want to remove the 5. Now notice I didn't say the 500. I said I want to remove the 5. And so the child has to think, in order to remove the 5, what do I need to subtract? So then they have to work out you would subtract 500. So if you have a look here, let's go back to the calculator. We've got 2,564. So I need to subtract 500, and that will take me to 2,064. If I had said, for example, we wanted to remove the 6, now notice I didn't say the 60, I said the 6, then the child has to work out what they need to subtract, in that case 60. So you could extend that to 2 decimal places. So I'll just explain to you how we'll do that as well. All I do is change the number that's on the calculator. So I'm going to put the number in here, 256 and 1400ths. So I'll show you what that looks like. So in this case here, we got 256.14 or 1400ths, that there. And if I said, okay, now if I wanted you to remove the 1 is in the 10ths place, then the child would have to subtract 0.1, and that would remove or wipe that number out. You see how that became much more complex when we changed the numbers. So the same game, we play with 3 digits is this difficult, 4 digits harder. Wow, when we get to 2 decimal places, it becomes quite difficult. So you see there, the calculator is actually not doing the thinking, the child is. So that's what I meant when I said we'd use a calculator for that purpose. Now, I just want to put a couple of other things up that may be useful. Let me show you a couple of other basic ideas. Now, this is just a flat game that we have, but what we've done is we've programmed it now so you can play it on the web if you like. So if you want to come into the website, you're welcome to play this game. Now, this one happens to be called Place Value Express 303. It's roughly for year 3s. Place Value Express 202 would be for year 2, 101 would be for year 1. Then there's a 404 and a 505. So basically, they get progressively harder. I'm just going to show you this one that's in the middle and talk a little bit about the language here. Now, when you play online, there'll be, you'll notice this is called Place Value Express. It's about, I like trains. So it's got a steam train in it. And so it'll blow some steam and that sort of thing. But let me show you how it works. So if you just like to focus on the board, and I'll show you what I mean. So in the board here, I would choose a number. So let's say I'm the red player, and I might choose, in this case, 2,348. Now it's interesting, in the United States, they don't put the and in there, they'd say 2,348. So some children, when they hear the word and, put in an extra 0. But in this case here, so I've now got 2,348, I spin, and the word I have to say is what digit is in the thousands place. Now in this case here, the digit that's in the thousands place is 2, and that means on the board, I just move ahead 2 places. Now that counter stays there for the whole game. That cell's been used up. Imagine I'm the green player, and maybe I choose, let me choose 7,236, and I spin, and it comes up, what digit? Now I've got to say, what digit is in the ones place? And the answer to that is 6. So the digit 6 is in the ones place, and so I move 6 spots on there, and the aim of the game is to get around the track. So as I said, we put up just to help you a little bit. We know you probably don't want too much screen time, but it's a bit hard to sort of, because it's A3 size, a bit hard for us to put it up to print. But basically, there's a Place Value Express 101, 202, 303, 404, and 505, and they progressively get more difficult. However, what this bit of place value was about a digit that's in a place. Now, just for your benefit as well, on YouTube, I think it's 17 to 20 different videos we just put up of ideas for place value. So you're welcome to look at them at any time as well, just as a bit of a background to that sort of thing. So I'd just like to sort of do one more sort of major idea in place value, and that's probably done your head in by this point here. But you see that place value is quite complex sitting here. Now, in addition to the other games I mentioned, we've put up another game, and I'll just show you how it works. And essentially, what we're doing is a pretty simple idea. This game's called Place Value Knockout, and it should be sitting up on the web. If it's not there now, it'll be there by tomorrow, sitting here. And I've designed this one just around 6-sided dice because you may not have the 10-sided. As I said, I quite like 10-sided dice because it has all the digits from 0 to 9. So there's what I mean by 10-sided dice is one that looks like this, okay, as opposed to your standard 6-sided. But we figured you may not have some 10-sided ones there. So here's our 6-sided dice. And in this case here, you roll the dice and you would have a board that's sitting here. And I might decide that I'm going to make a particular sort of number. So I'm going to make 5,235. And so you see I've arranged the dice like that. And then what I'd need to do is cover those numbers on here. So that's 5,000, and then I've got 200, and then I've got 30, and then I've got 5. So now I've taken up all those spaces on the board. The next player rolls the dice, and they would make the same sort of idea here. But what they're aiming to do, it's not such a good number we rolled because we got 2,222. And look here, you got a problem because I can't put a counter on that one there, so I don't get a go. So the idea is after so many turns, how many counters have I got on and so forth. So all we've done here is take some standard dice that are available and just put a board up that makes it a bit simple. Now, I just want to make a couple of other comments about material that may be useful and things that you might be able to sort of download from the web in that sense. Now, there are things called place value cards, which I'll talk about in a minute. In the UK, often they use things called arrow cards, which I really like. And if you just do a search on arrow cards, you'll be able to find some to print out. But I'll just show you how they work, and that'll sort of tidy up this sort of session for now. So I'll just show you these couple of ideas. So essentially, we have some cards here, and all they are is, you notice there are certain lengths, and you'll see that this one fits under here and so forth. And essentially what we're doing is splitting up or partitioning a number. And so you can see that the number 784 is made up of 784. But we also need to be a bit more flexible in our thinking. So I want to talk about a couple of other ways that we might split or partition that number. So it was 784 and we split it by place value, 784. And look at a couple of other ways that you might do it. So if you just have a look back down on the screen here, there could be 784, or it could be 784. So we've got those sort of different ideas that sit there, and it gives us a bit of a notion of how we might split. Now, in terms of other cards, we can use things called arrow cards, and as I said, very popular in the UK. So same sort of idea, but you basically layer numbers to sit on. So that's 370, and I just layer it on. What I really like about arrow cards is that the way that arrow set is I can start now putting in, for example, the decimal and the idea that we've now got 370.9 or 370 and 9/10. So when you layer that on top, you'll see that sort of come out there. So they are sort of just a little brief overview of place value and some of the key ideas there. Place value is quite complex, and don't be surprised if some children have trouble with it, because they may not realize that every time I move a place to the left, I'm multiplying by 10, and every time I move a place to the right, I am dividing by 10. And that's a bit difficult for some children to do. So basically, I hope that's sort of a nice little encapsulated bit about place value. There's a lot to take in, I appreciate there. But hopefully the extra videos we put up will sort of explain that a bit further. So thanks very much, Heather, for hosting from your empty house today. We appreciate you've been in the midst of moving. Pretty difficult when you got all the social distancing as well. So poor old Heather's children are in the shed, basically. So I feel a bit sorry for them. So thanks very much, Heather.